Alright, so the information we're going to be using for the pre-work here is going to be I'm taking this from an old test that I had. It'd be ideal, of course, when you're out there, it's going to all be real information with a real nautical almanac, but like I said, we're doing this from 1981. So here we got the current date and time. It's December 12th. The current time is 18:30, which of course is 6:30 p.m. Our DR position at that time, this is zone time. Our DR is 24 degrees, 16 minutes south, and 041 degrees, 18 minutes west, and that's at the DR. Our course is 235 degrees true. We're going 16 knots. So that's what we know so far. And you can do this at noon, you can do this at 8 a.m. It doesn't really make too big of a difference, but you do need to DR out to the time that you think is the star time. So first of all, we're going to figure out what time that is, what time we need to go out there, walk out on the ship, walk out with our sextant and shoot some stars. So on December the 12th, I'm going to open up the Nautical Almanac here and find December the 12th. These pages inside the Nautical Almanac are December 12th, 13th, and 14th. 12th, 13th, and 14th. Over here you have Aries, and you have the planets, and you have a bunch of stars. Over on this side you have big stuff like the sun and the moon. You have the twilights right over here. So what we're going to be looking at is I want to find star time for where I think I'm going to be. So let's see, my current latitude is 24 degrees south, so I'm going to look in here, right in this area. This is sunset. Remember, we're looking for civil twilight right here. So 20 south, civil twilight. Looks like it's about they do it right here for both the 12th, 13th, and the 14th. It's close enough that all those days the numbers are right about right. So civil twilight at 20 degrees south is at 18:59, and that is local mean time. 30 degrees south, the civil twilight is at 19:23. And that's LMT. These are all LMT times, local mean time. Now, we're only going 16 knots. This is at 18:30, and you can see that civil twilight is pretty soon. It's like in 20 minutes from right now at the earliest, or give or take. This part, it's not too important that you're spot on, so I'm going to do a little bit of shooting from the hip here with some of these numbers, but it should all work out fine. So I'm going to DR out only 1 hour. I can see that part of this is 1900 basically, and the other part is 1930. The current time is 18:30, so I'm just going to DR out 1 hour, but it is important that you do that DR out so you can get some good numbers to go from. But like I said, right now we're looking for star time, which is civil twilight. So our actual latitude is right here, 24:16, so that's somewhere right in between these guys, south. But I'm going to shoot from the hip here. And I'm just going to estimate that 20, 24, and 30. 24 is right in between these two pretty much. And this is in between 1900 basically and 1930, so 1915, local mean time. Now I need to change that into zone time, which is the time that's on my watch. So I'm going to run this DR out a little bit right now. We are doing 235 in this direction, which is pretty much down here. It's bigger than 180, which is this way, 180, and it's smaller than 270, so I'm going to draw the triangle like this. Bada bing. 235 minus 180 is 55. I'll plop that right in there. And in 1 hour I go 16 nautical miles. So this side of the triangle right here, 16 nautical miles. And this position right here is 24:16 south and 04118 west. And now I just need to do a little bit of really exciting trigonometry. So this is going to be x, this is y, sine 55 is opposite over hypotenuse, x over 16. 16 sine 55 equals x. I already got 55 in my calculator. So I'm just going to hit sine times 16. 13.1. 16 cosine 55 equals y. 55 cosine times 16, 9.2, give or take. So this side right here, 13.1, this side over here, 9.2. Now it is true that if you're doing sailings, this doesn't work because you're getting further away from the equator, and the nautical miles does not equal minutes of longitude, or minutes of latitude for that matter, as you get further and further away from the equator. But for our purposes, we're just doing a DR, so I'm just going to go ahead and roll with this. So I'm heading down to the left, that's more south. So I got 24, 16, I'm heading more south, so I'm going to add 9.2. 24, 16. 25.2 south. And right now I'm in the western hemisphere, and I'm heading more west, so I'm adding this. You need to kind of say this in your head, because as you go from one hemisphere to the other, or as you go from east to west, these things you can really wrap your head around them. So you need to figure out however it works for you in your mind, if you need to add or subtract this stuff depending on your heading. So here I'm at 41, 18 west, and I'm going more west, so I'm going to add 13.1. 41, 31.1 west, 24, 25.2 south. That right there is my DR for 1930. I'm looking up here. This is what I originally came from is 1830. This is my DR for 1930 on December the 12th, right here. Now, I guessed up here that civil twilight is at 1915. This is the DR where I'm going to be, where I think I'm going to be for 1930. We need to change from local mean time into zone time. So I'm going to use the DELO method here. So 31.1 minutes is like half a degree. So 41.5 divided by 15, I get 2.7. So I'm in ZD minus 3. And I know that because 2.7 is close to 3. So the time zones, which you should learn on your own, 3 times 15 is 45. And I can see right here that 45 is close to this, less than 7.5 degrees away, which is half of a time zone. I'm just going to keep moving through this because we've got a lot of stuff to get through today. ZD minus 3. So I need to figure out what my DELO is. The center of the time zone is 45, 00, but I'm going to rewrite that as 44 degrees, 60.0 minutes. And then I'm going to subtract 41 degrees, 31.1. I rewrote that, and I'll use this trick pretty often throughout the day. It's just carrying over a number when you're not using, and when you're using minutes and seconds, it makes life a lot easier.